Continuing our 2.8 discussion, we'll do another example here. Again, at any point, feel free to pause and try these yourself. Also a reminder that you could solve these in more than one way. I'm just showing one pathway. If you go and explore a different route, you should be getting the same answer. So feel free to pause it, try it. Here's what I did. I looked at equations 1 and 2. I noticed the x's would cancel there. I wouldn't even have to multiply or change anything. So the x's cancel, combine everything else, get your y's to make 3y. Negative 2 plus the 1z here makes negative z, and 5 and 2 make 7. I switched gears to equations 2 and 3. I did take equation 2 and multiply by 2. Again, my focus here is to get rid of the x, since that's what I started with. Whatever you cancel first, you want to continue to cancel that. So those should cancel, combine the y's, combine the z's, combine your numbers. Now I have two equations that just have y and z. I even kind of lucked out because I have a positive z and a negative z, so I can actually just use those together. The z's would cancel out, and I combine my y's, combine my numbers, and now I have a variable. I got y equals 2. Got one of my answers. So just start plugging it back in. You can pick either this equation or this equation. In this case, I picked the one with the 7, plug in the 2 for the y, and I'm going to solve for z. So you got 14 there, move the 14, so z is negative 1. Finally, I got two answers. We need to find the third. Go back to any of these three here. Looks like I chose the top one, but any one you pick will get you the right answer. Plug in your number for y, plug in your number for z, start to simplify things, and as you solve, you get your answer. So just remember, x goes first, then y, then z. All right, hopefully that worked, even if you tried a different method. Again, feel free to pause, try this yourself. I chose 1 and 3, and I multiplied the first one by negative 1 just to change all the signs. Let's see what happens. I combine, and I get some x's and z's, but my y's are canceled. Okay, save that for later. I didn't chose 1 and 2, and I multiplied equation 1 by negative 5. This changed everything in here, and actually what happens is that all of the x's, the y's, the z's, they all eliminate. So I'm left with 0 on the side. The other side would just be negative 7. I can stop right here. That doesn't have any variables, and this doesn't make any sense. It's a false statement. So there is no solution for this one here. If I had actually just started with 1 and 2 and done this first, then I would have got to that answer a little faster. Sometimes you get there on the first step. I just explored this route, and then the next thing I did led to a no solution. All right, let's see what else we got here. Again, feel free to pause, try it yourself first. Here's a pathway I took. I looked at equations 1 and 2, realized that the z's would cancel out this time. Got an equation that has 2x and a minus 2y equals negative 6. All right, put that on pause. Went over here and I used equation 2 and 3. Again, I didn't need to change anything. So you have to be strategic here, like which numbers can you easily get things to cancel on. So now my x's combine, my y's combine, my z's cancel. Now I got this. So I got two equations. Here I do need to multiply though. So in this case, what I did is I took this equation and multiplied by negative 3 to everything. And over here, I just left it the same. So those are gonna happen. I've kind of looked at on a few of the other examples where things just were ready to eliminate, but you could always multiply, just like I multiplied other equations. Actually, what's unique that happens here is the x's and the y's, they both eliminate, leaving 0, but this side is also 0. So that's a true statement. So that tells me that there's infinitely many solutions. All right, let's try a word problem. This could be the most difficult part is usually just setting it up. So let's see what we got here. And this kind of guides us as well. So feel free to pause and read through the whole thing. We got different types of memberships here. If you look at it, we have a total of 81 new memberships. So if I take my number of individual ones, my dual memberships, and my family memberships, I add each of those up, it's 81 memberships. The number of dual memberships purchased is twice that of individual memberships. So what I need to do here is do twice the individual memberships would equal the dual ones here. All right. My last equation is going to involve all the money. So it's 60 for each individual one, 80 for each dual one, 100 for each family one for this total amount of money that they brought in. So there's my three equations. All right, let's go to the next page and we'll solve it. So I just rewrote the equations. Notice this one here is rearranged. So I took the equation I had, y equals 2x, but I wanted it in standard form. So I moved the 2x over, and you could rearrange it lots of different ways, but that's where this one came from. Let's see what we got here. I'm actually going to start with 1 and 3 because equation 2 is actually kind of in a good position. It already has just x and y, no z. So I think my target here would be trying to get rid of the z. All right, if I can get rid of z on these two, then I have a second equation I can already work with. So I multiplied the first equation by negative 100. You might see some big numbers. Feel free to grab a calculator. But that should get rid of my z's over here. And now I just got my x and my y equation. So I can use this equation along with the second equation to get something to work out. I did multiply this equation by a 20 to get a negative 40x and a positive 20y. So the x's don't cancel, but the y's do. And now I got this negative 80x equals negative 1680, and I can divide, and x is 21. So there was 21, I believe that was the individual memberships. Let's just find everything else, so plug it back in. The easiest place would be to plug it right in there. So 21 times 2 would be 42, so there's 42 of those types. I think that's the dual membership. And then just pick one of your equations. Probably the top one would be the easiest. All of these had to add up to 81, so just plug in everything you know and find z. So there was 21 individual memberships, 42 dual, and 18 family memberships.